Hi everyone, Assalamu alaikum. This is Amal Muhammad, and today I'm gonna show you how we make the 3D model for the main hub for the quadcopter design. As you can see, this is the finalized main hub, the semicircle one, and we choose this design due to its various advantages, such as, for example, it's empty from inside, so it allows the user to install the electronic and control devices inside. And the second one is that is aerodynamically efficient compared to the previous drafted sketches for the quadcopter design. And today I'm gonna walk you step by step on how we did this 3D model. First of all, we did the arm connector. And this is first we made a circle out of 200 millimeter of diameter. And this is the arm connector with its relevant dimension. As you can see, the base here is quite wide. Also the height with the 40 mm cross section. And basically it's quite large because it's gonna connect directly to the arm, which going to also connect to the motor housing as well as the propeller. So it should endure a lot of weight and not fail. So that's how we did this arm connector. And then finally, before we add it, we have to trim it from here so it won't be overlapping sketches. So the pad will cause an error. So after we finished this sketch, we executed the band option, as you can see, with the relevant thickness of 5 mm, which we thought it will be sufficient to sustain the weight of the arm, motor housing, as well as the propeller. Okay, so after we did the arm, after we padded, or rather I did the circular pattern. We choose a complete crown option with an instant of 4. So we need just 4 arms, and the software will automatically calculate the angular distance or spacing between them. And this one is the reference element, which is the z-axis. So these arm connectors will rotate about the z-axis. And finally, this is what we got after we circular pattern the arm connector. Okay, after we finalized with the arm connectors, we did the coverage, or rather the sealing for the base. Okay, and this is okay. This is how we ensure that we design the interior of the main hub as empty. So here we have two arcs, the one at 210 millimeter and the second one at 200 millimeter with a thickness obviously of 10 mm. And this is how we ensure that the interior will be empty and not solid body inside. And here the base is 2 mm, is 2 cm, which is 20 mm from the base. So it will add additional stiffness or additional material. So this will help to keep the interior parts as safe as possibly can. So the way we did the cross section like that is that because we wanna shaft it or use the shaft command. So we will make sure that the inside is empty. So we check here first of all the the axis of rotation is z-axis, and then for example if we put 270 and hit preview, we will see the interior parts with this additional protection for the electronic and control components. So let's make it 360, so it will be closed. Okay, that's how we finalize it. After that, we did the rotate command. So as you can see from here, these arms were where the original arms were created and circular pattern, but we don't wanna the arms to be at 90 degrees or at 0 degrees from the X and Y axis. We rather want them at 45 angular distance. So we will have this shape. This is the most efficient way for the quadcopter designs and how do they flow, and also for stability reasons. So this is the angular spacing between them, 45-degree angle, and the rotating axis is the z-axis. So hence we have this 45 angular spacing from the main sketched arm. Okay, so we don't want this arm sketch design. Okay, after that, what we did is the connecting was the connector bracket with the landing arms as well as the payload compartment. For that, we first executed a plane, a separate plane, even though it is at 0 mm from the XY plane, which is obviously on top of the XY plane, but we reference it in a separate plane so we can have complete freedom on how we can change it and also edit it without abusing the main design, which is the main hub. Okay, so after that, we did the sketch, which is named here 11. This is actually the connecting brackets, and actually this one, okay, we used our creativity on how we made it, on how to ensure that the edge does not over or rather under edge the main hub at a diameter of 200 mm. So we constrained it on the circle and also for the other four edges. And most importantly for the design and for this mounting bracket design is the thickness. So we maintain the thickness of 5 mm, which we think it will be sufficient to sustain the housing the compartment the payload compartment as well as the landing arms. Okay, so after we finish the sketch, we exit the sketch pane and then we pad it as well. So this is after we pad it with a length of 20 cm. So this will provide additional spacing for the holes where all the other parts will be connected. So as we said earlier that we maintained a diameter for the holes as 5 mm. So this one will give us sufficient room for the bolts or for the holes where we can sketch it on top of this mounting bracket. So that leads us to our next step, which is the holes. These are the holes. First one, this is the hole at a diameter of 5 mm, and that's basically how you constrain it. It is at 10 mm from the top and 25 mm from the far edge of the connecting bracket. So after you positioned your hole, so you can choose what kind of hole or setting of holes you want. We choose the up to last, so I don't have to make other hole from the other side. So it will just make the hole and pass it through any solid object all the way to the end. So that's how you just shortened one more step to create the hole from other side. Okay, so and then after we make this hole, we just have to rectangular repeat it at an angular space, not a linear spacing, or rather, yeah, spacing, straight spacing of 100 mm. It's not angular spacing, so therefore we have this other hole. And also the reference element is the y-axis. We want this 100 mm. We want this second instance, second hole, to be at 100 mm from the first one, moving in the y-axis. That's how the rectangular repetition command works. Okay, and then after we repeat this one for the connecting arms, we did the holes from the other side. For the payload compartment where it will be attached. And the same step, we did the hole with the dimension of 5 mm up to last, and also from the positioning sketch you can see that's how we position, or rather constrain our hole, the center of our hole, at 10 mm from the edge, from the top edge, and 45 mm from the far edge. So yeah, we executed, hit OK, then boom, it created from both sides. And then, excuse me, the final step, which is rectangular pattern, this one at the other side. So as before, we want an instant and spacing. So I want 2 instance, which is other one, and I want the other hole to be at 60 mm from the first hole, and the moving or the reference element to be moved in the x-axis. Hence we have this one here. Okay, so this is the finalized main hub after we completed each and every step on the design. It is basically quite simple, but it needs a lot of practice, maybe on how to use the shaft command and the rotate command. These are the most difficult thing, if I would have to say. And the holes and the repetition pattern is either rectangular or circular, are the main key on how to do a lot of things in a shorter amount, in a shorter time. So yeah, this is the finalized one. Thank you everyone, and stay tuned for the other parts.